DOM-based cross-site scripting is short for Document Object Model-based cross-site scripting. And this one is characterized by the fact that the injected script never actually goes back to the server. It actually just stays in the browser the entire time. So inside of Matilda here, we have this HTML5 web storage page. And when you go to this page, you'll notice that down here at the bottom, you can add a new key and a new item if you want. And so if you want to make it a little easier to see what's going on, what you can do is you can delete some of the items that are already in there. That'll just clear up the page a little bit. So whenever we enter a key and an item and then click the add new, you'll notice what happens is a new line gets added to the table. But this information is not actually being sent all the way back to the server. What's happening is whatever you type in here is just being added to the page by the JavaScript on the page itself. So this data is never really traveling across the network. It's just being read by the JavaScript program on the page, and then that local script, if you will, that's only running inside of this one browser goes ahead and adds this information into the page. You can see these scripts. You can just do Control U in Firefox, or you can do View Page Source in any browser, and then scroll down to the bottom where the local scripts are that do all the work. When you get down near the bottom, what you'll see is the scripts that are adding information to the page. And right in here is where the table gets built. And then eventually what you'll see is that a message gets posted, and the vulnerable function that needs to be fixed in this application is right here. We have the message span.innerHTML. So the innerHTML function is vulnerable to cross-site scripting because it does not output and code the information. And the developer should have used inner text here instead, and that would have prevented the HTML elements or script elements from being able to be written to the page. But again, this document object model based cross-site scripting is simply being input on the page. The JavaScript on the page itself is picking it up, passing it into this function here to this variable pMessage, and then the parameter pMessage is being set by the inner HTML function as a child of the message span. And you can see that here. So the message span is appearing right here between in this phrase where it says added key, and then we typed in canary to session storage, and then you'll also get some output in this table. So let's watch what happens when the key is not just a piece of text, but that is actually HTML. So we hit add new, and then here you can see what happened is this script, this H1 script, which just makes letters big, actually defaced the page because the browser is now confused. Even though we inputted this information is what's supposed to be data, the browser can't tell the difference between these script elements here and data, so it just interpreted those scripts the way it usually does, which is as HTML. If you use the inner text method, what happens is this information that is input is no longer ambiguous anymore, and you can see the effect here in the table. Notice how all the data that was typed in is simply printed out on the page. It isn't executed at all. There's no confusion here because an inner text is used. But down here where there's an inner HTML, the browser wasn't sure which part of this was data and which part of it was script. So the parts that looked like script, it just went ahead and ran. But hopefully that helps explain the document object model or DOM-based cross-site scripting. And the key point to remember is that the injection does not travel back to the web server or come from the database. It is injected and stays on the actual page rendered in the browser itself. Effectively, it never leaves the browser at all.